Good morning students, welcome to the session of data structures. In our previous lecture, we have completed a data structure called array. Okay, arrays, in a previous last session we have done with the advantages and disadvantages of your array, and also we have discussed applications of your array. Both the topics are very important for your 4 marks. Go through them, and if you are having any doubts, just let me know. Okay. And before that, we have discussed about n-dimensional array and 2-dimensional array and 1-dimensional array, how they are going to store the elements, what is the memory representation, how we will be finding the address of array elements, that we have seen in our previous lectures. Okay, in our today's lecture, we are going to see the new data structure called stack. Okay, while I have discussed the types of data structures, we have categorized them. Mainly I have categorized them into 2 types, I can say. One is linear and the second one is non-linear. See, in a linear only we have discussed about arrays, and the second one is linear linked list, and the next one is stack, and the next one is queue. These are the types of linear data structures. Okay, this data structure is categorized into linear data structure, non-linear data structure. In our linear data structure, we have discussed about the arrays, and we left with linear linked list, stacks, and queues. Now, in today's session, we are going to discuss about the stack. Now, let us try to understand what is data structure called stack. In what way we are going to store the elements in our stack data structure, and how we will be accessing them, and how we will be utilizing them. What are the applications of stacks, and what are the operations that we would perform on your stacks. Okay, now let us try to understand what is stack first. Okay, see here, stack is also a very commonly used data structure in your programming session that they are saying. By using linear linked list also you can implement the stacks. By using arrays also you can implement the stacks. By using both of them you can implement what? Stack data structure. Okay, and stack holds what? Objects, usually all of the same type. Why? Because in case of array also we have seen it is a collection of similar data type elements. Okay, here also we are using the arrays to implement stack. That is the reason they are saying that they will be holding the same type. Okay, even sometimes we will be utilizing for different kinds also, but as of now, do remember that it will be holding the same type. Okay, and see, next one is it follows the concept of LIFO. It is the main point that you should remember about the stack. It is following a pattern called LIFO, last in first out. Either you can go for reverse order also, that is first in last out. Sorry, first in last out. Both means for the same thing. Okay, here it is saying that last in first out. I am saying that first in last out. Both means for the same thing. This is the data structure that we are going to follow. It is following the pattern called LIFO, last in first out, or else you can write first in last out. Okay, stack is linear. Stack is a linear list of items in which all additions and deletions are restricted to one end. See here, if you are storing the data elements in your stack data structure, we are going to store the elements like this. So consider this is a container. This is your container. Then we will be having an end point here. From this end part only, we will be inserting the elements and we will be deleting the elements. That is what they are saying. Addition and deletion of the elements are restricted to one end point. From here only I will be inserting the element. If I am inserting the first element as 1 will be inserted, and if I am inserting the 2, then 2 will be inserted, 3 will be inserted, like that I will be inserting the element. But when I am deleting the element also, I won't go for the next end. I will be using the same end in order to delete the elements. That is the reason we are following last in, first out. I have lastly inserted 3. When I am deleting, 3 will be deleted first. 3 will be taken away from your stack. And then 2. And then 1. Like this, we will be following the pattern called last in, first out. Okay. Some languages like Lisp and Python do not call the stack. They won't use the stack implementation. But however, it will be having push and pop function. That is what push is nothing but insertion of elements and pop is nothing but deletion of elements. These are available operations on your stacks that they are saying. And we will discuss the last point in later session. But see here, in order to understand this concept, go through these particular examples. In our daily life, we will be using the stacks. Okay. See here, a stack of cafeterian trays. See here, trays are arranged in the stack format. Why? Because we are having a table. On that table, I have kept one tray, first tray, and then on that tray, I have kept the second tray. On that, I went for third one. On that, I went for fourth one. On that, I went for fifth one. See here, it is already kept on table. When I want to take a tray, then I won't go for the first one and I will be pushing it out. But I will be taking the first one that I have inserted lastly. That is what last in, first out pattern. So fifth tray that has been kept in the last one, that will be taken first. Okay, and we will be utilizing and will be putting on to the same tray. Okay, like that we will be inserting the elements from the one end only and we will be deleting the elements from one end only. Here it is a stack of pages. Okay, here we are inserting the coins, or else we are putting the coins. I can say we are putting the disk one after the other, then it will be containing a stack like this. When you want to take out, you will be picking out the last that you have inserted, that will be taken away. Okay, see the stack of shoe boxes, and I am putting that shoe boxes one after the other, then I will be picking the last box that I have kept on the stack. Okay, when I am arranging my shades like this, I will be arranging. When I want to take out the shade, I will be picking the last one. I won't go for the first shade that I have kept. Okay. In the same way, you can go for the similar kind of examples. See, in this we have arranged the books. If you want to take the third book from this, then you need to remove all those books and then you should go further. If you are directly trying to remove that, then other books will fall down. Like that, we will be utilizing the stacks in our real life also. But in this session, you should remember only 3 points. That stack is a linear data structure. Stack is a linear data structure and it will be following LIFO structure, LIFO pattern, last in, first out. Okay, and then the next point is stack is a linear data structure where it will be using only one end in order to insert the element, in order to delete the element. In order to insert the element also, it will be using the only one end. In order to delete the end also, in order to delete the element also, we will be using the same end. Say suppose your stack will be like this. Okay, we will be having an end point. So when I am trying to insert the element from this end, I will be inserting the element, first one. I will be inserting the second element. I will be inserting the third element. Like this, I will be inserting from the end. From this end only, I will be taking out my elements. The last element that I have inserted, that will be taken first, and then next, and then next. Like that, we will be following what? Last in, first out pattern. Do remember these 3 things, and we will discuss what are the operations that we can perform on the stack, what are the stack ADT operations that we could perform, how it will be implemented, how we will be writing the program for stack ADT. Okay. If you are having any doubts, just let me know so that I can clarify you people and we will go for the next part. That's it for now. Thank you.